Given A is 3 comma negative 2, B is 2 comma 6, and C is negative 1 comma 4, we need to find the component form of vector AB and the magnitude of A to B. Well, the component form of AB is equal to the equation x2 minus x1, y2 minus y1. Now, first of all, since we're going from A to B, that means that point B will be your x2 and y2, and point A would be your x1 and y1. All we do is simply substitute the values. X2 is 2 minus x1, which is 3, and then y2 is 6 minus y1, which is negative 2. Simplify this, gives me a negative 1, and make these positive, 8. So here I have the component form of vector AB. Now to find the magnitude of AB, remember magnitude is denoted in absolute values. Magnitude also means length. And the equation is the square root of x2 minus x1 squared plus y2 minus y1 squared. Note, because I have the component form right here, I don't have to use the distance formula. I could simply just go to my x component squared plus my y component squared, which actually means less work because right here I already computed what x2 minus x1 was and what y2 minus y1 was. So this gives me the square root of negative 1 squared plus 8 squared, which is equal to 1 plus 64, which is equal to the square root of 65. So here we have the magnitude, of AB, and over here we have the component form of AB. Part B is done the same way. I need to find the component form of BC right there, and I need to find the distance from B to C. Again, since I'm going from B to C, that means that C is the x2 and the y2, and B is the x1 and y1. Starting off, vector BC in component form is equal to x2 minus x1, y2 minus y1, which is equal to x2 is negative 1 minus 2, which is x1, y2 is 4 minus 6. This is equal to a negative 3 and a negative 2. The magnitude of vector BC, which is written in absolute value, is equal to the square root of x squared plus y squared, which is equal to the square root of negative 3 squared plus the square root of negative 2 squared, which is the square root of 9 plus 4, which is equal to the square root of 13. Here is my magnitude, and here is my vector in component form. Hopefully, this will be enough information for you to find C. Please hit the pause button, which I believe is located somewhere down here or here, and work this out. Well, hopefully you hit the pause button and you did your work. Here I have the solution. Remember that because I'm going from C to A is my x2 and y2, C is my x1 and y1. And right here, the square root of 56 could be simplified to the square root of 4 times the square root of 14, which is 2 radical 14. I think the biggest thing you have to be careful of, I know I do, is keep conscious that it's x2 minus x1 over y2 minus y1. And you're always used to working with slope, or at least I am, so I have a tendency of writing a y2 minus y1 up on top and then putting the x2 minus x1 up on bottom. That's just out of a habit of finding slope. So be very cautious of that. I hope this is useful. Please let me know.